So hello everyone, this is our second live class, and this live class ends part one of this course. In part one, we discussed the basics of Python in preparation for advanced Python topics for us to jump into developing for production. In week one, we looked at how to set up our environment. We saw the syntax of writing Python codes and how we can write comments in Python. We looked at how to declare variables and the rules for naming variables. We looked at the different data types, and then we look at strings and the different methods that we can use to manipulate strings. You can watch the pre-recorded videos in the class to refresh yourself on these topics. These are basic topics, and we will not want to touch back on them. In week two, we moved on to looking at logical operators and the Boolean list, and we looked at list comprehension and how to sort lists. And then we also looked at tuples. We moved to looking at sets, dictionaries, conditional statements, loops, and functions in week three. And in week four, we looked at lambda functions and user input. We looked at the date and the math methods. We looked at modules and how to import new files or other files into a new file. We look at regular expression and error handling in Python. And then in week five, we looked at how to handle files. We looked at higher order functions. We looked at decorators and how we can manage resources in Python. Today, we are going to summarize all of this and pick out topics that we have noticed from your assignment submission might be a little challenging. And then we are going to move on to start a little more advanced topics that we will meet in week 6. We have said that Python uses indentation as its syntax. And when we say indentation, we mean the spaces before the block of code. And we use indentation to indicate blocks of code. So for instance, if we use a for loop, we say for I in, let's say there's a hypothetical variable called persons. So let's say for I in persons, we want to loop through. Now this automatically gives us the indentation, which are the spaces before, to indicate that this is all a block of code. So that is what we mean by indentation. We are going to look at the variables and then look at list in more details, and then we'll move on to look at functions. Now, when we name variables, we just mean that we have a container for storing values. These values can be a single value or it can be multiple values. Now, Python do not have arrays. We use lists and other collection types like sets, loops, and dictionaries. We name a variable by writing a variable name. Now, the rules for naming variable is that you can start with an underscore and a letter, or you can start with a letter of the alphabet, either upper or lowercase, but you can't start the name of a variable with a number. While the variable name can contain numbers and characters, the number must not start the name of the variable. It can contain underscore and alphanumeric values in the names. The names are case sensitive, so when you write first name like this, it is not the same thing as writing first name like with uppercase letter like this. So there are two different things. So when you name variables, you have to take note of these rules and that they are case sensitive. We also do not want to use a Python keyword as a variable name. For instance, we don't want to use print as a variable name because print is already a keyword in Python. So we don't want to name our variables with a keyword. When we name variables, we can name them in different ways, especially variables that contain more than one word in their name. Let's say we want to write a variable called my student like this. It can be difficult to read. So you can use something we call camel case, which will make the first letter of the first word start in lowercase, and then the first letter of subsequent words start in uppercase. You can use snake case, where you just use an underscore between new words like this. Or you can use Pascal case, where you capitalize every first letter of every word like this. So you choose one convention and you stick to it. And sometimes when you develop, your team will have guidelines and conventions that you use, and so you want to stick to the convention that is defined for your project. When we define a variable, we can assign either a single value or multiple values to the variable. When we have a variable, let's say first name, written like this, and the first name is a string, we either write it in single quote or in double quote like that. And then if you refer back to your pre-recorded videos that you watch for week 1, lesson 5, you will see the different string methods that we can use to manipulate strings. Now, when we say string, it's not usually just only one word. Sometimes you can have multi-lines of text in a string. And for these multi-lines, you can use single or double quotes, but you use 3 quotes. And so you can write a whole block of text and end with 3 quotes. So either single 3 quotes or double 3 quotes. You start with the same, end with the same, like that. And then you can write your block of code here. Let's say, the quick brown fox jumped over the little dog. Let's call this sentence as the name of the variable. Let's call this sentence trial. The quick brown fox jumps over the lazy dog. And then let's write several of the same thing and just assume that we're writing a long sentence or paragraph here. So you can write your strings like this with triple single quotes or multi-quotes to have multi-line text. And when we say we'll print sentence, then we have it printed. We have an error. The name is sentence trial. And when we run again, we have it. Now, if you learned HTML before, we know that when we write text in multi-line in HTML, it doesn't automatically format within a paragraph. You need a break tag. But in Python, it is formatted and you will get the breaks inserted in the same position as the code when you write strings in Python. Okay, any question?
No question.
Okay. So let's look at lists, because from your assignment submission, we realized that a lot of you have problems with list and list comprehension, which is a critical topic you need to understand before we move to the advanced topic. Now, lists are created using square brackets. So the first thing you need to remember is, how do we create lists? We can create a list using square brackets, or we can use the list constructor. So let's say people is equal to a pair of square brackets defines a list, and let's say the people that we want to define are, I'll put Mildred, let's say Mary, let's say Jane, and let's say John, let's say Joseph, and we'll just put the last one and we'll say David. So we have a list. We put items within square brackets. These items are separated by commas. Now the item can be of any data type. If a string is quoted, if it's not string numbers, you keep the same rules of the data type, but the list can take any data type, and they are indexed. Lists are usually ordered, they are changeable, and then also allow duplicate items in the list. And so when you have a list that have duplicate items, when you want to change this list to have only the unique values, you convert that list to a set, because sets do not allow duplicates. And if you watch your pre-recorded video for week 3, lesson 1, you will find that we gave detailed description of sets, the methods for sets, and the characteristics of sets. Now these are indexed. Let's say we want to look at items on a particular position. Indexing starts at 0. So we have 0, 1, 2, 3, 4, 5. Although we have 6 items, the index position ends at index position 5. It starts at 0 and ends at 5 for 6 items. If we want to look at the length of the list, let's say we want to print out the length. Let's say we use the length function. We print length people. So we see that the length is of length 6, but the index positions are 0 to 5. And if we want to print out an item at index position, let's say we want to print out the third item here. The third item will be at index position 2. And so we will say print, let's say people, and then in a pair of square brackets, we put the index position 2. And it will print out Jane, because Jane is the third item, is at 0, 1, 2, index position 2. Just the same way as we do slicing with strings, that is how we do slicing with list. If you want to know the data type in the list, or if you want to know the data type of this variable people, we know that the function that we use to get data type is the type function. So we can say print type people. And when we do this, we'll see that the type is a list. So people is of type list. Now, we want to use a list constructor to make a new list. And we want to do exactly the same thing we've done, but this time we want to look at the alternative way of creating a list. We use square brackets here, but you can use a list constructor to create a list. Let's say, for instance, I have a list called my list, and I want to create a list. I'll use list. When you use a list constructor and you want to create a list with items, you must use double round brackets like this, double brackets. So it will be in parentheses, but it's going to be double parentheses. If you are creating an empty list, then you just put the list constructor with a single parenthesis like that. So because we want to list item, you use the list constructor like this, and you list the item in another parenthesis within the list parenthesis. So let's say we want to list new item. Let's say we have Mildred, we have Joseph, we have let's use a number here. We have number 40. We have, let's use the Boolean true. We have let's use a name now. Matthew. Let's stop here. So we have my list, and we define this with the constructor. So this will name this in snake case like this. So we have the list constructor naming this. We want to see if this actually works. Let's try to get the items at index position 1, which is the second item. So we can say print my list, and then in square brackets, we want to print the item at index position 1. It prints Joseph, which means it works. This is using like positive numbers, but we can use negative slicing. Let's say we want to print the last item in the list. We don't know what the last index position is, but we want the last item of the list. We can say print, and then the name of the variable that holds it, print my list, and then in a pair of square brackets, the last is indicated by -1 like that. And when you do that, it prints the last item, Matthew, to the screen. Okay? Any question? So when you use positive numbers, index position starts at 0. 0, 1, 2, 3, 4. When you use negative slicing, it starts at -1, -1, -2, -3, -4, -5. So when taking your quiz, we have a lot of questions on string methods that we use slicing like that. You want to be able to index them positively and negatively, and be able to know what slice, start and end position will print a particular item or a particular selection of item in the string or in the list. We can use a range of index and to get a particular item. Let's say we want item at index position 1, 2, and 3. So we want to get items Joseph 40 and through. That's 1, 2, 3. And we don't want to get it like print my list 1, my list 2, my list 3. We can do something like print, and then in a pair of square brackets, this is where we do the slicing. The start position is at index position 1. We want to print Joseph 40 and through, so 1, 2, 3. The last index is not always inclusive, so to print this third one, we have to include index position 4, which will not be printed. Remember that when you specify the end index, it is not inclusive, it is exclusive, which means if you want to stop at 3, your last has to be 4. So if I want to print this, I'll print my list 1, 4 like this, and when I do this, it prints Joseph 40 and through. If I stop at 3, 3 will not be inclusive, it will be Joseph and 40. Okay, if we want to print everything from the beginning and end at 40, let's say 0, 1, 2, we can say, since we start from the beginning, we can omit the start position. We'll say my list, omit the start position, and just put this and we want to stop at 0, 1, 2, and the last index is not inclusive, so we'll say 3. And then when we stop, it will print Mildred, Joseph, and 40. If we omit the end, it will print from the specified start to the end. So when we say my list and then we omit the end, we say we want to start from index position 2 and omit the end, and then when I run this, it will print 0, 1, 2, so it starts from 40 through Matthew to the end. Is there any question?
No question.
Okay. So when you want to change items in the list, you do this by reassigning the index. For instance, we have index position 0, 1, 2. We want to change this at index position 2 to something else, maybe to a name. So what I'll do is just to say my list and the index position is 2 is equal to, and let's say Peter, and then I'll say print my, or let's say 4. Let's print out everything in a loop for I in my list. We want to print I, and when I run this, there's no parentheses in the print. We have it printed out like that. So we've replaced 40 to Peter here. So when you want to replace item, you can do that by reassigning the value at that index position. You can change a range of items. Let's say we want to change index position 0, 1, 2. So we want to change Mildred, Joseph, Peter, which are the new list items. We want to change everything in that range. What we'll do is say my list, and we are changing from index position 0 to, so we're changing 0, 1, 2. The last is not inclusive, so we'll do 0 to 3, and we want to change this one is equal to, and then we'll create new items to change them. So let's say I want to put Mary, Martha, and Grace to replace them. And so when I say for I in my list, print I, we'll see that the Mildred, Joseph, and Peter, which was replaced in this one, is going to change to Mary, Martha, and Grace, like that. So have Mary, Martha, Grace through 40. So you can replace a range of items by specifying the index like that. Okay. If in the event that we want to do this, but we specify a range, and what we list here is more than the range, let's say we want another name here, Daniel. This is 4, and we only specify 3 index. It will shift accordingly, and just shift the other items from the end and change the index position of the other items, putting this one in the next position like that. So it has Mary, Martha, Grace, Daniel. So it shifts through to start at index position 4 instead of 3 where it was before. So that's what will happen. It will not result in an error, but it is going to shift the items. We can insert items at a specified index. Let's say now we have Mary, Martha, Grace, Daniel, True, and Matthew. So let's just redefine the list so that we will have the list that we are using. So let's say my list is equal to, or let's create a new name. Let's say list items is equal to John, Jane, Grace, Solomon, Daniel, Luke. So we have new list items like this, and we want to insert an item at a specified index. Let's say 0, 1, 2. We want to replace Grace, or we want to insert something here at index position 2, which we push Grace to index position 3. So if we want to insert item at a specified index, we do something like let's say list items dot, we have an insert method that we use, and then we specify the index where we want to insert. 0, 1, 2, we want to insert at index position 2, and what we want to insert in place of Grace is, let's say, Glory. And then when I say print for I in list items, I want to print I, and when I do this, I have Glory at index position 2 and Grace moved to index position 4. That's how we use the insert method to insert at a specified index. We can add item to the end of the list. Let's say we want to add James to the end of the list. What we do now is to write list items dot, and we use the append method like this, and what we want to append is James. And when we say for I in list items, print I, we are going to get James added to the list. So we'll no longer have 7 items, but we'll have 8 items in the list. If we want to remove items from a specified index or from a specified position, or want to remove a specified item, so instead of append here, we want to remove, let's say for instance, we want to remove Solomon. We can say list items dot remove, and then what we want to remove is Solomon. And when we print this, Solomon is going to be out of this item because we've replaced it here. So after Grace, we get Daniel, and Solomon is out because we use the remove method to remove. If you don't specify the item to remove, we can use a pop method. So I'll just copy this to make it fast. I'll say dot pop, and we can decide to just put an empty parenthesis. This will remove the last item, which is James here. And so when I do this, the last item, James, will be taken out. If we specify what to, like in the pop method, we can specify the index position of what we want to remove. So if we say list item, let me put this, dot pop, we specify we want to remove the item at index position 0, which is John, and when we print, John is out of the list. So these are the different methods that we will need as we go advanced. How we manipulate lists. We will use this. If we want to completely delete a list, you can use delete list items, and this item list will be completely deleted. If you try to print, you get an error because we have deleted list items here. So let's try. and we'll get an error because list item is not defined because we have deleted the list. Let's say we don't want to delete this list and I want to clear the items in the list. I can do list items dot clear method like this, and then there's no item in the list, so we'll have an empty list. So sorry, I'll have to redo this. Let me use another item because I've deleted this previously and I don't want to restart this. So let's use the other one, my list. So my list dot clear, and when you try to print my list, there are no items in my list. Sorry, I have to change this to my list. And there's no item in my list because we use the clear method. Okay, so when we want to loop through a list, we use for in loop that we've been using. So refer back to your pre-recorded video on for loops or on loops, where we discuss in details in loops, and I think that is on lesson 4 of week 3. So your pre-recorded videos are very important because we go into deep details about the topic, especially during the basics, because this is an advanced course and we do not want to sit down in a live class and baby you into the course. We expect that by now your logical reasoning should have been expanded to the point that we have live classes every 2 weeks where we compress the topics and you have an opportunity to ask questions of anything you are not clear about, and then we're able to touch on the parts that we did not explain in details in the pre-recorded videos that you get every Friday. Let's take a look at looping through this list and writing the code from a whole block of code to just one line of code using list comprehension. So when we use list comprehension, we use it to create, most of the time we use it to create a new list based on the values of an existing list. And so let's do that. I will create a new list. Let's say this is named, let's say this list. And this list contains, let's say contains numbers 1, 2, 3, 4, 5. This list contains number 1 to 5. We want to create a new list from this list. And let me say I will use the list constructor to create an empty list like this. So I have an empty list created there, and I want to put items in this list. I want to loop through this list and add 2 to that list. So I want to loop through it, add 2 to it, and put it in the new list. So that's what we're going to do. So I'll say for I in this list, we want to say do something. We want to take the new list that is empty, and we use the append method that we learn about to add items to a list dot append. And what we want to do in the parentheses of the append method is say I plus 2. Okay. So for I in this list, new list dot append I plus 2, and then let's say we want to print at the end of the whole thing, print new list, so we can see what it was in the new list. So let's run this and see if it's working well. Sorry, new list, new underscore list, and then we'll have it 3, 4, 5, 6, 7 because we're adding 2. 1 plus 2, 3, 2 plus 2, 4, 3 plus 2, 5, 4 plus 2, 6, 5 plus 2, 7. And so this is how we have done this. But we have a shorter, neater way of writing this. We have this list defined above there, and we can say we want to use list comprehension. And the syntax of list comprehension is to put your square bracket. You write the expression first, and then if you have a loop, you put there, and then the condition comes after like this. So our expression is, we want to append, this is the expression, add new items to it. So let's redefine the list and just do it as a whole here. Also, I'll copy this and I'll say What I want to do now using list comprehension is to do something like this. I will say new list, because the expression comes first, dot append, and I want to append I plus 2. We don't know what I is, and the next thing we want to say is now the loop for I in this list, right? And if we have a condition, we will put it there. If we have an if condition, it will come after this, but there's no if condition. This is all we want to do. And then what we want to do at the end is to print out new list for us to see if this was appended. Print new list. So when we print this, we should get exactly what we got in the first time, because now what we just did is put all of this in one line here, and we call this list comprehension, and then we do this, and we have exactly the same answer. So list comprehension is something you have to practice to be able to write all of your loop and everything on one line. So it will be more useful when you have a longer block of code where you put for this and this, if something happens, do something else, and it's just a whole long line of text. Okay? So we might want to say the way we want to print this out, for instance, is not to write print new list. From there, we can say something like new list is equal to, let's say, new list is equal to, let's do list comprehension. We'll say I for I in this list. And then now we can say we print new list. So now we're just printing exactly this list back. I will say I plus 2. So let's say print new list. So let's see this. So we have the same thing. So you see, different ways of doing list comprehension is something you have to practice to get into the flow. There's no other formula for knowing how to do list comprehension. It's just about practicing it with different scenarios. Start with very simple short codes and then move over to using longer codes to do list comprehension. Is there any question?
No question.
Okay. We have something we call the sort method, and this sorts alphanumerically in ascending order, but it's not very good at sorting numbers, because when you have something like 121, 80, 70, it is going to sort 121 as smaller than 80 because of the number 1 that comes first. And then we have a function that we use to make this sort possible to sort numbers. Refer to your video, to pre-recorded video, for you to see the details of how we did that. And we did that in lesson 4 of week 2. But we're going to look at sorts generally and how we can sort a list. So we have, let's say we have a new list. Let's just write final list, and then we'll have final list is equal to red, yellow, green, blue, and we want to sort this list. So let's say we want to print final list dot sort, like this. So it's going to sort alphanumerically. When we say alphanumerically, it sorts letters and then it sorts numbers, but it doesn't sort numbers correctly by default. So when we do this, it's ascending order by default, and when we print this, we have none, final list of sorts. So let me do it the other way. Let's say print final list, and here we'll just do final list dot sort, like that. And when I do this, it sorts this in alphabetical order. If I want to sort in descending order, I will say final list dot sort, and here in a pair of parentheses I will say reverse is equal to true. Okay, and when I do this, it will sort in descending order. When I print final list, and so we have it yellow, red, green, blue. When I don't want to sort, but I just want to reverse the list, I will do final list dot reverse like this. And what will happen is that it's going to, let me print final list. And then we have it reverse, blue, green, red, yellow, not sorted, but reversed. Because we sorted before the reversal, it's just reverse the last one. So no, it keeps the last thing we've done with that and the last value that it has there. So take note of the difference between reverse and sorting in descending order. They are not the same thing. And because sorting is case sensitive, we know that it's case sensitive. Uppercase and lowercase sorting matters when you have items that are in different cases. If you want to make it case insensitive, you want your sorts to go case insensitive, let's say we have this in green and this in yellow like this, and then let's print it out differently. The capitalization matters. You see the sorting is now altered by the capitalization. But for us to make this not happen, we'll say key is equal to string dot lower. Let's say final list, or let's say string dot lower like this, and then let's try this and see, and then it sorts it out, taking the case into consideration. So when you say string dot lower, it just means that you want to sort in sensitive sort. Any questions before we end the topics of list and move on to another topic?
No question.
Okay. So we have discussed function previously, and we say a function is a block of code which only runs when it is called. And the beginning of part 2, we are going to start looking at function on a deeper level. And so let's refresh on the topic of functions so that your week 6 will be more understandable when we look at functions in deeper details. So it's a block of code that we write to reuse multiple times. And anytime we call this function, it is going to do something. Maybe we want it to return a value, want it to print a value. For this, we are going to use print, but when we start developing our system, we're going to use return so that we can always call. We don't want to print into the screen. We want to return a value, and maybe we want to do something with the value, maybe send it to the database or something. But for us to be able to see what we are doing, when all the testing phase, we are going to be doing print statements. We also learn about modules, and we said that module is like another Python file that we have different functions and method in that we want to use on a different file, and we use the import statement to include that file on a different module. So let's say that we want to write a function that calculates the area of a circle anytime it is called. We want to write different mathematical functions for our students, and or let's say the app we are designing is an examination app or a calculator or something, and we want to have functions, helper functions that we call to do a particular thing when a button is clicked. The first thing we want to do is to import a Python inbuilt module we call math. The math module holds different mathematical functions and methods. It holds several things like the value of pi, all of those mathematical statements that have values. We have those values in the math module. You can read about the math module and look at the different methods that it has and what the method too. But now I import math because I know I want to use the pi, and pi is defined in the math module. And when I call pi, all that will happen is that I will get the value of pi. So I want to create a function. A function is created using the def keyword, and I'll give my function a name, any name I want. I'll call my function area circle, something like this. And then I want to say this function is going to take an argument. So what I will do is I can have a function that in the parentheses of the function definition, it can be left blank. The function will just do something when called. I can have a function that we pass arguments into the parentheses when we call the function. For this function, we want to define parameters within the parentheses. So parameters and arguments can be used interchangeably, but normally the definition is when you are defining the function in the parentheses, it is called a parameter. And when you are calling the function in the parentheses, it is called an argument. So I want to supply. So when you hear arguments or you hear parameter, most of the time people use that interchangeably. So I want to define this, and what I will need when I define the area of a circle is I want to know the radius of the circle. So I want the parameter here to be the radius so that the user will supply the radius as an argument to the function call. So the def area circle, and I want to say the radius. And what I want this to do is to just print directly. So I won't say return. Normally I will use a return statement if I'm building my software, but because we are testing, I want to print for us to see the value. What I want to print is math.py. Pi is the method in the math module. So I call the module name dot the name of the method I want to use from the module times, and we know it's pi r square, so we'll say times radius raised to the power of 2. So we know the different operators in Python, that exponentiation is double asterisk and multiplication is asterisk. We know the order of precedence. We can use parentheses first. For the first thing we want, radius has to be calculated first before we multiply by pi. So we print math.py times the value of radius that will be supplied as the argument raised to the power of 2. And when we call this function, let's call this function area circle, and I want to get the area of a circle whose radius is 20, I will just get it printed to the page like that. So this is one way of creating a function that takes arguments when the function is called. We define the function with a parameter in the parentheses of the function definition. And sometimes we want to define functions that do something when you start creating your software. We don't know in advance the number of arguments that the user will supply. And so when we are defining the function, we have to take into consideration that we do not know how many arguments the user will pass into the parameter. What we do in this instance is, let's say we want to create a function that returns all the members of a particular family. So I'll say def, let's say the family last name is the Petersons. So I'll say def the Petersons like this. I'll say def the Petersons in the pair of parentheses. I want the members, but I do not know the number of members that the Petersons family has in advance, and I am not going to just restrict the number that they can use. So what you do when you want them to be able to supply any number of arguments is to use an asterisk before the parameter that you define. And so this way, they can define any number of arguments when they call the function. So I'll say for I in the Petersons, I want it to just print I. So we can print to see all of the members of this. So now we have defined the function. We want to call the function the Petersons and supply arguments in the function call. So now we want to say this has James, has Jane, has Sarah, and has Solomon. So you see we have 4 members of this family. So we want to say for I in, not the Petersons now. We want to say for I in the members now, the parameters that are defined. So for I in members, we want to print I. Here we are printing out. So let me go over this again. The definition is we are defining a function that takes any number of arguments that we do not know in advance. And we want to define that in the function definition that the parameter we define will know that the users can supply any number of arguments. We use an asterisk before the name of the parameter, and we want to print out all of the arguments that are supplied by the user. So the argument is the members that will be supplied, and so we'll say for I in members, print I. And so we want to call the function, the Petersons supply argument here. We call the function a second time, we supply any number of arguments, and let's say this time we'll supply only one argument, and we'll say Daniel. And so we'll have 2 printouts. So we have James, this is James, Jane, Sarah, Solomon printed out the first time, and the second time we have just only Daniel printed. So we can delete one to see that it can take any number of arguments and will not result in an error because we put an asterisk before the name of the parameter in the function definition, which means that the users can supply any number of arguments. Is there any question?
What if the parameter is empty? Is that still possible?
Okay, so now we'll do the Petersons and we have nothing to print out. You have no error, but you have nothing supplied. So what it means is that you don't know what the user will do. So the asterisk covers for that. So when you call the function without anything in the parentheses, there is nothing for it to loop through, there's nothing to print out, there is no error produced. Okay, so you can play around with all of this, go through all that we have discussed, try to create your own new functions, expand on the knowledge of the topic. We are going to look deeper at functions, higher order functions, map functions in our part 2 advanced class, where we look at this in deeper details. So good luck in your part 1 test, and ensure that you go through weeks 1 to 5 lessons in greater details and practice as much as possible in preparation for the high speed and the complexities of the topics we are going to discuss in part 2 and in part 3 of the course. If there's no more question, this is where this lesson ends.
Thank you.
All right. Thank you, and see you in the next 2 weeks.